In the second part of 4.5, we're going to be talking about quadratic systems. What that exactly means is that we're going to be looking at systems of equations in which one of the functions is a quadratic equation or a parabola, and the other equation is linear. When we look at those, you could have three different types of situations or solutions. You might have a situation where you have a parabola and the linear equation goes through it at two specific points, in which you would have two solutions. You might have a situation where the linear equation only kind of touches that parabola at one point, giving you one solution. And finally, they might not even touch at all, in which case you would have no solutions in that case. So we're going to look at these in two different ways, solving by graphing and solving by algebraically or by substitution. To solve by graphing, this equation is asking which y values would be solutions of the following system. Y equals negative x squared plus 5x plus 6, and y equals x plus 6. Now, we've learned for both of these equations how to graph these by hand, but since we're going to be using the calculator to find an intersection point, don't worry as much about how to graph either of these lines. I would more just focus on looking at the situation, seeing how many solutions, and knowing how to find that in the TI Inspire, which we'll go over in class. If I were to graph these in my calculator, I would have a parabola that looks like this, and I would have a linear equation that looks something like this. So here, just by looking at this picture, I can see that I have two solutions. In the TI Inspire, I'm going to learn where to find these. Looking at this graph, I see I have solutions at 0, 6, and 4, 10. So in this equation, they're asking what y values would be solutions. I would say the y value solutions are at 6 and 10. And then I'd be done. That would be my answer. The next thing that I want to look at is solving by substitution or solving algebraically. Here I have a similar situation, and they want to know what is the solution or solutions of the following system. Y equals negative x squared minus x plus 6, and y equals x plus 3. So if I want to solve algebraically, first I'm going to take a look at the fact that both of these equations are equal to y. So using what I learned in substitution a couple chapters ago, if they both equal y, I can set these equations equal to each other. So I'm going to write out my new equation as x plus 3 equals negative x squared minus x plus 6. From here, I have an equation that's similar to what I've been working with throughout this chapter. I want to get everything to one side or to equal 0, and then I can go from there. So first, I'm going to add over my x squared. That doesn't combine with anything, so I'm left with this. And from here, I'm going to add x to both sides, and I'm going to subtract 6 on both sides to get my one side to equal 0. And I'm going to be left with x squared plus 2x minus 3 equals 0. So now I'm left with a simple factoring equation. So looking at this problem, I want two numbers that multiply to give me negative 3 and add to give me positive 2. My only factors of 3 are 3 and 1. If I make this guy negative, 3 plus negative 1 gives me 2, so that's going to work out. I have x plus 3, x minus 1 equals 0. So learning what we learned previously the day before, my x value can either be at negative 3 or I have a solution where my x value is 1. The last thing that I want to do here is figure out what my y coordinate would be in these situations. So what I'm going to do is plug in for both situations. Now to find my y coordinate, I can technically plug into either equation, but the linear one's going to be a lot more easy. So while you could technically plug in this negative 3 to the parabola, make your life easier, just plug it into the bottom equation. So when x equals negative 3, y equals negative 3 plus 3 equals 0. So I have a solution at negative 3, 0. I also have a solution at 4. And my coordinate here would be 1, 4.